Welcome to my Advanced Database Management System course. In this section, we discuss about transaction management, transaction states, transaction, commit, rollback, and save point. Let's enjoy. Transaction management is a crucial aspect of database systems that involves the management and control of database transactions to ensure their atomicity, consistency, isolation, and durability, ACID properties. Here are the key components and concepts related to transaction management. Transaction. A transaction is a logical unit of work that consists of one or more database operations, such as inserts, updates, deletes, that are executed as a single unit. Transactions are typically initiated by applications and are executed by the Database Management System, DBMS. ACID properties. Transactions must adhere to the ACID properties to ensure their reliability and consistency. Atomicity ensures that transactions are either fully completed or fully rolled back if an error occurs. Consistency ensures that the database remains in a valid state before and after the transaction. Isolation ensures that transactions execute independently of each other. Transaction states. Transactions typically progress through several states during their life cycle, including active, partially committed, committed, and aborted. In the active state, a transaction is executing its operations. Upon successful completion, it enters the partially committed state before finally committing its changes to the database. Transaction control statements. DBMS provide transaction control statements to manage transactions effectively. These include begin transaction, commit, rollback, and save point. Begin transaction marks the start of a transaction. Commit saves the changes made by the transaction to the database. Rollback undoes the changes made by the transaction and restores the database to its original state. Save point creates a point within the transaction you can later roll back. Concurrency control. Concurrency control mechanisms ensure that transactions execute concurrently while maintaining data consistency and isolation. Techniques such as locking, optimistic concurrency control, and multi-version concurrency control, MVCC, are used to manage concurrent access to shared resources and prevent data corruption or inconsistencies. Transaction isolation levels. Transaction isolation levels define the degree of isolation between concurrent transactions. Common isolation levels include read uncommitted, read committed, repeatable read, and serializable. Each isolation level provides a different trade-off between data consistency and concurrency. Transaction logging. Transaction logging is the process of recording all changes made by transactions in a log file before they are applied to the database. Transaction logs are used for crash recovery, rollbacks, and maintaining durability. They ensure that changes made by committed transactions can be replayed in case of system failures. Save points. Save points are markers within a transaction that allow you to create named points to which you can later roll back. Save points provide a way to create intermediate rollback points within a transaction, allowing you to undo changes made up to a specific point without rolling back the entire transaction. Distributed transactions. In distributed database environments, transactions may span multiple database systems or nodes. Distributed transaction management ensures that transactions across multiple databases maintain ACID properties even in a distributed environment. Techniques such as two-phase commit, 2PC, and distributed locking are used to coordinate distributed transactions. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson.